All right, hello everyone. Welcome, welcome. Let's go ahead and get started for today. Our first task is just to kind of take a look at the calendar because we're nearing the home stretch here. There's actually only 5 weeks of class left, including this week, so not too much left to go. In this class, what we have remaining is one more round of 3 new topics. So we've got 3 new topics coming, 3 new pieces of information coming your way in the next 3 weeks, and then we've got one more exam. That exam will be on April the 17th, right here is where it is. For a lot of you, hopefully most of you, that'll be your last exam, because I'd like to remind you that you do get an exam drop. And for a lot of people, that means that they get the good grades on exam 1, 2, and 3. Then they choose to use the drop on the final, and that's totally fine with me. That is not a problem at all if you want to drop the final. But if you want to take the final, please note that the exam time for the final has been shifted. The university shifted our final exam time back a few days. It used to be on the 28th, but it is now on the 2nd. It's on May 2nd. So just want to make sure you're aware of those 2 very important days coming up. But otherwise, you just owe me the usual. We've got 3 more assignments for the 3 new units of material. And we actually have 4 studios left. There's kind of a little extra bonus studio at the very end that's not really related to any of the modules, just kind of a little extra bonus one. And the quizzes, and yeah, that's what we've got left to go. Speaking of exams, as you hopefully saw, or maybe are seeing right now, I just posted the exam 2 grades not that long ago. It was like within the last hour or so that I got all that stuff finished up and posted. So just like with the previous exam, regrade requests are open. Any regrade requests that I get by a week from now, by next Monday, will be accepted, and I go through all those personally myself. So take a look at your exam, and if you have any questions, you're certainly welcome to talk to the TAs or even talk to me about it if you want to. But if you really want a regrade request, you have to submit it through GradeScope. So the TAs won't be able to help you with that. You really have to submit it through GradeScope. I think that's it as far as announcements and logistics go. Does anybody have any questions about what's coming up the next few weeks, or exam 2 stuff, or the last month of class or so before we hop into today's materials? Any questions? Great. Awesome. Then let's talk about objects. This is a very, 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 very important topic. In fact, we've basically been working all semester up, building you up to get to this point. This is kind of the destination. This is what all of the stuff that we've been teaching you is meant to sort of come together and be used for. We're going to be creating and using objects today. So this is a very kind of different way of thinking about programming. Before today, it's been very much start at the beginning, run your way through the end, and that's actually still true. But the objects are going to bring in a lot of different ways of thinking about code. We have this concept in computer science called programming paradigms. So it's just different ways of thinking about programming and different ways of conducting programming. What we've been doing up until now, I would call more procedural programming, writing lots of methods and calling methods over and over again. What we're going to start doing today, and we'll be doing for the rest of the semester, is under the umbrella of object-oriented programming, which is by far the most dominant programming paradigm. Although we are seeing procedural programming make a comeback, interestingly enough, in recent years, but this idea of object-oriented programming is really not going to go away anytime soon. And we're going to spend a lot of time today just kind of introducing this concept, trying to wrap our minds about what it means to be using objects, starting with something that we've shown you in the very first day of class, but didn't actually tell you about. I promised you and promised you and promised you we would eventually come back and talk about what this stuff is, and today's the day. We're going to start talking about what some of these magic words are and what they actually mean, starting with these 2 that I've got highlighted right here, or specifically this one. It's what I'm very interested in talking to you about today. A class is something that every Java program we've ever written has come with, right? We haven't actually used them before today, though, because classes directly relate to this idea of object-oriented programming. Classes are essentially a blueprint or a specification, if you want to think of it that way. It describes what a class contains and also the behaviors that that class can perform. So those are the two main categories of things you're going to find in a class. Let's start by looking actually at the stuff that we see right up here at the top. This first stuff, this is new. This is different from how we've been doing these things before. These are called instance variables. So you can think of instance variables as almost like blank entries on a form, right? When I create a specific person, I have to fill these instance variables in. So I am telling you in this class that I'm trying to represent a person, and there's a relationship that we use between a class and its instance variables. I would say has a. It's a very important relationship. So a person has a name, a person has an email address, a person has a phone number. If you try it with stuff that doesn't make sense, right? You might say, a person has a price. What? That doesn't really make any sense, right? Like that doesn't fit in the person class. That fits in a product class, or something that I wish to buy. So using this has a relationship can help us. I actually will say it out loud, or in my head I'll say it out loud. Class has this, just to kind of logically check and make sure that this instance variable makes place for the class, for the object that I'm trying to represent. Notice that these are all marked private. So instance variables are always, always, always going to be marked private. At least in this class. I don't know what other professors are telling you, although I hope that they also tell you to mark your instance variables private. I believe very strongly in that ideal. And I'll explain a little bit more about what it means to mark them as private and why we mark them as private a little bit later on. But after the instance variables, I think it's important to talk about another very important part of our class, something that I'm going to start expecting to see. We haven't seen any of these today, but we definitely will start seeing them a lot more from here on out. This is called a constructor. So the constructor's role in life is to create what is called an instance. That is a very important vocabulary word, instance of a class. So this person class is really just a blueprint, right? Sometimes the analogy that people will use is that it is a cookie cutter. So in order to actually make cookies, I have to apply the cookie cutter. I have to stamp out a brand new cookie. That's creating an instance. I'm using the class to create an instance of a person. And so that instance is going to represent a very specific person. It could represent me, right? It could represent you. It could represent the person sitting next to you, or your mom and dad, or whoever you want it to represent, right? But the thing to keep in mind is that all persons will have a name, an email, and a phone number, and chances are that these will be different, right? Because my name is Doug Shook, and that's different than what your name is, and that's different than the name of the person sitting next to you. And the same for email address, and the same for phone number, right? So all persons will have these things, but these values will all be different for each individual person. Or will they? I mean, it's actually very possible for two people to have the same name. That actually happens all the time. So will they be the same? Will they be different? Well, yes and no. Some of both, right? Some of both. But this idea that it is a separate entity, it is a separate instance, is very important. I'm going to draw a diagram a little bit later to hopefully illustrate that concept in a bit more detail. But let's return our attention to the constructor. Constructors are very important. So before the constructor is used, I have nothing. I have instructions, right? But I don't actually have any objects. I don't have any instances. I call the constructor, and after the constructor runs and does its thing, I now have something. So I have an instance of an object. Constructors bring new objects into the world, and the way that they do that is by setting all of the instance variables. So we're filling in the blanks. Constructors are filling in what those blanks should be. And you can see the way that most constructors do this, although there are other ways that you can go around this, go about doing this, is by taking in parameters. So that means that if I want to create a new person, if I want to create a new instance of a person class, you have to tell me what their name is, what their email address is, and what their phone number is. I will pass those into the constructor. The constructor accepts those and sets the instance variables. So think about what that means. If I have 3 instance variables, then I expect to see 3 assignment statements inside of this constructor that accept these values from the parameters and store them in the appropriate instance variables. If I had 5 instance variables, then I would expect to see 5 assignment statements here, 1 for each of the instance variable. It is the constructor's job to make sure every instance variable is set to an appropriate value by the time it is finished. And that's it. That's all it's supposed to do. That is all that it has to do. Is make sure that all of the instance variables have appropriate values. So let's take a pause for a second and come down here. If we take a look, this is the main method, and it's still very much true that the main method is the entry point of our program, right? So here on line 27, this is actually the first line of code that we would expect to execute. And this line of code is calling the constructor. You might be wondering how I know this. The constructor is always going to have the same name as the class. So you can see that I'm in the person class. With a capital P, that's very intentional, that's capitalized. This constructor also has that name, right? What is the constructor? The constructor, how would you categorize this? Is it a variable? Is it, what is it? Constructor is, starts with an M. It's a method, yes. Constructor is very much a method. I said earlier I was going to call the constructor. We call methods. The constructor is a very specific kind of method with a very specific purpose. Constructors are used to create instances of objects. That is their role in life. So down here you can see that whenever we call the constructor, we use the new keyword. We've actually seen that before. Spoiler alert, you've actually called a constructor before. Anybody remember where we've seen this new keyword pop up? I heard somebody whisper, scanner. That's right. Scanner is where we saw that pop up before. Scanner is an example of an object. Now, I didn't make that class, right? That's just provided to us by Java. So some things are given to us for free to use by Java, but other things we wish to create and define ourselves, and that's what we're working on now is how do I create a new class? How do I create a new object that does what I want it to do? Whoops, sorry about that. And so anytime I call the constructor, I'm going to see that new keyword, and here you can see the parameters coming in. This is the person's name, their email address, and finally their phone number. And this is going to create an instance of the person class and store it in the variable called P1. And now is where I get to show off my beautiful MS Paint skills and draw a little bit of a diagram to show you what exactly, how I envision this process happening. Whenever I call the constructor, I usually represent instances as a circle on my diagrams, although it doesn't really matter what the shape is, right? It could be a square if that's what you would prefer. And then inside of the circle, I like to think that I'm going to see one entry inside of this circle for each of the instance variables. And so I know that for person, I'm going to have a name, right? And I'm going to have an email, and I'm going to have a phone. And when I call the constructor, I am filling in these values, right? So for the first constructor that's being called here on line 27, I'm putting Sana in the name field, right? I'm putting, sana@gmail.com in the email field. And then I'm putting, who cares? Doesn't matter what the actual phone number is. Putting phone number in the phone number field. So this is my object. Right? After the constructor is called, before it was blank screen, white, nothing on it. After the constructor is called, this exists. This is an object. This is an instance of an object that exists. And then, furthermore, I am taking that instance of an object and I am storing it in a variable that is called P1. So the way that I like to represent that on my diagram is by drawing an arrow. Although we do have a technical term for this arrow as well. Right? This arrow, I would say, is called a reference, or you might hear it described as a pointer, because it's quite literally pointing at something. And really, we're just assigning a label to it, right? So, you know, P1 is pointing at the instance of this object. So this line of code that I am running right here, right, has the effect of creating this instance and also creating a reference, which is really just a variable pointing at that instance. I know I'm throwing a lot of stuff at, there's a lot of new vocab words coming at you, so if anybody wants me to back up, re-explain part of it, re-explain some of those vocab words, I'd be happy to do so. I promise it'll start making sense as we start doing more and more stuff. Because let's talk about the other category of things that we're going to find in classes. So we have instance variables. Actually, I say other category. There's two categories. There's two things I'm going to find in classes. I'm going to find instance variables, and I'm going to find methods. So I already talked about one of those kinds of methods called the constructor, but we're also going to have just other regular old methods too. Not, non-constructors, like the kinds of methods that we've already been writing. And so the difference is, the big difference is that these instance variables, we say they have class level scope. Remember that word scope? Which means that I can access them in any of these methods in the class. And that turns out to be a very powerful concept. So here I have a method called print. And it does exactly, as it says. It's going to print out all of the instance variables. So you can see here, these ones that are highlighted in blue actually represent instance variables. This email is the same variable as this one, right? Which is the same as this one. You can see it's even highlighted up here. Those are all referring to the same exact variable. That's not something that we've been able to do before today. All of our variables before today were created within methods, and we're only able to be used from the methods where we created them. So that is much more of a procedural style of programming. Object-oriented programming says that these variables belong to the class. They belong to the instance, and therefore I can use these instance variables across any of the methods that exist within the class, and that's a very, very powerful technique. So what happens then when we have a method like this? In order to use this method, since it relies on these instance variables, right, I can't use this method until I call the constructor first. In other words, I can't just call print directly. I must have an instance upon which to call this method. So the print method requires that before I can even call this method, before I can even use it, that I have called the constructor and I have initialized all of these instance variables. If I didn't do that, then think about what would happen. This would be empty, blank, error. I'm not really sure, right? Undefined, right? If I try to use this method and I haven't called the constructor, then these have never been set. So who knows what they are? Could be anything, could be nothing, could be anything in between. So we call the constructor, and then we call the method upon an instance. And here is where we see that down here in the main method. Recall that before I created this instance and I stored it in a variable called P1. If I want to use the print method, I cannot just say print by itself. It won't let me. That is an error. I must say P1 dot print in order to use that method, which says run this method using P1 as the instance, right? So think about what that means. I think it might help if I look at this other piece of code down here. This is going to create another person. So if I look at this, I'm calling the constructor. I know I'm calling the constructor because I see that new keyword. That's a big flag, right? Anytime you see that new keyword, I want alarm bells going off in your brain that I'm about to create a new instance. Before I had nothing, now I have an instance of an object. And so if I look at line 30, try to represent that on my diagram, it's saying, oh, call the constructor. We're going to make a new instance. We're going to fill in the values just like we did with the last one. They're different now, though. The name is going to be Jean or Jean, I guess, depending on if they're French or not. And email address. And then phone. Sure. And then just like we saw before, that instance is being created and stored into this variable. So we would represent that on our diagram by having an arrow or a reference pointing at this instance labeled P2. And I went through this all just to try and illustrate, right? Just to try and demonstrate this concept of when I call print, what do I use for the name, the email, and the phone number? What do I, right? What values do I use here? Do I use the values from P1? Do I use the values from P2? Do I use the values from, you know, some other person that I have laying around? The answer to your question, the answer to that question is look here, right? If I call print upon P1, that says go follow the arrow P1 and use this name, use this email address, and use this phone number. If I call print, but I see P2 on the left-hand side of that dot, then that says go find, you know, this instance of the object and use this name and this email address and this phone number when you use that method. So the instance variables that we find are going to be substituted in anytime we call a method, and which instance variables get used depend upon which instance that method is called upon. It's a very complicated concept that I just dropped on you, but it's also very important. So if anybody would like for me to try and clarify or go back over any part of it, I'd be happy to. Yes?
So what's an object?
What is an object? I mean, an object is, an object I would say is an instance, right? This is an object right here. The circles, these are my objects.
They can stuff within the circles.
Those are instance variables. So objects contain instance variables. That is the attributes that describe what an object is. And then instances also contain methods that are the behaviors, right, that an object can do. So those are the two distinctions. Those are the two distinctions there. Yeah. But under object-oriented programming, I cannot use the methods until I have created an instance and I have specified what these attributes are. That's a big difference from how we've done things. Was there another question? No? Okay. And so, you know, I kind of want to run this through the debugger as I like to do with different problems, just to kind of illustrate what that might look like from a coding perspective. I hope the diagram helps as well. But let's go ahead and set a breakpoint right on the very first line, which is line 27. Okay. Switch over to our debugging perspective, right? My computer is running a little slow today. What's up with that? There it goes. All right, so here I am. I'm paused on line 27. I haven't actually run it yet. And you'll notice over my variables window, I really have nothing. There's nothing exists. So once I call the constructor, once I run the constructor, you can see that, oh, now I have something. So the constructor actually created a brand new thing for me to use and manipulate. And it's called P1. And you can see that over here, it's given the type isn't int, the type isn't double, the type is person. I think that's another very important idea, very important concept. Anywhere that I can use a type, I can now use person. So I could use person as the type of an input parameter to a method, right? Down here I use person as the type of a variable. So before today, we would have seen, you know, int P1 or double P1, but now I'm saying person P1. I'm using a class, I'm using an object type there, right? It's a very powerful concept. And if we look at what's inside of this object, you can see there are the 3 instance variables as well as their associated values that were passed in to the constructor. So what happens when I call p1.print? If I step into this method, we can see, okay, there's this keyword this, which I'm going to talk about a little bit later. But if I look, if I expand that out, you can see that, I see there is the stuff from P1, right? So the print method got called upon P1. So it's going to print out P1's information. And that's exactly what it does. Prints out the name, email address, and phone number. And then when it's done with that, it creates a new person, P2. And now I have 2 instances, so now it matches the diagram, right? Here is person 2 that is a distinctly separate instance from person 1. So when I call p2.print, even though I'm calling the exact same method, right, I'm calling it upon a different instance, so I don't see the same information come back out. I'm going to see the information from p2 come out instead. I'm not going to step through that method this time. I'll just step over it to show you that we now see both person's information displayed on the screen. Any questions before we move on to our next example? Any questions? Okay. So then if we take a look at this exercise real quick, just to get some more practice with filling in the different parts of a class. I'm looking at the riddle object. Riddles, it says riddle has a question and a riddle has an answer, right? Those both match the has-a test. So we have to decide on what the types of those things are going to be. And since they're both, you know, we're telling like a joke or something, it's probably going to be strings for each of them. And then the last thing to remember is that all instance variables should be marked private. Don't forget that part, because if I just say string question and I leave off the private, you'll notice that Eclipse isn't mad at me, but I will be if you do this on an exam, because this is not private, this is actually public. If you forget to put the private on there, it is the same as typing the word public in front of it, which we do not want. And I promise you I will explain that in just a moment. We are getting to that. But all instance variables should be marked private. So the answer will also be a string and will also be marked as private. The constructor here has been started for us. That's kind of nice. You can see we've got 2 parameters coming in. I will set, you know, this one is clearly meant for this instance variable and this one's clearly meant for this instance variable. So my constructor is going to have 2 assignment statements, one that sets the question instance variable and one that sets the answer instance variable. And then we have 2 methods, although these are both very short, very sweet methods. One of which is going to print out the question, and one of which is going to print out the answer. And we're now done with this extremely simple class. There's not a whole lot of complicated stuff happening in this class, but it's good practice to see all the different parts. Let's call the constructor to create 2 new riddle objects. So in order to do this, think about how we're going to call the constructor. We also want to store it in a variable. So the first thing we're used to doing is typing out int or double or boolean. But what am I making now? I'm making a riddle. So I'm going to use riddle with a capital R, the same as the name of the class. And I'll call it joke1, right? That's just a variable name. Equals, anytime we call the constructor, we have to use the new keyword. The name of the constructor is going to be the name of the class, which is actually the same as the type. right? So this is always going to match the name of the constructor. This word and this word. I suppose that'll change actually a little bit once we talk about inheritance next week. But for this week at least, this word and this word will always be the same. Always. They need to match. And now we just have to pass in our parameters. We have to tell it what the question and the answer are. So I might say, you know, why did the chicken cross the road? Other side. Cool. So there's one riddle object, but it asks us to create two of them. So we'll repeat this object for a second riddle. Oh my gosh, I'm drawing a blank here. What's brown and sticky? A stick. I know, it's a dumb joke. My kids love it though. Okay, so if we're thinking about things in terms of, you know, the diagram in our heads, which I sometimes quite literally have one of these, like in my heads, or if it's a particularly complicated program, I may even take the time to sketch it out, just like I've done here. I generally prefer paper over MS Paint if I'm going to do that option, but, you know, doing the best I can in the situation. So yeah, that's effectively a similar situation, except instead of name, email, and phone, we have question and answer. And so when I say joke1 dot print question, right? It's not going to ask me this joke. It's going to ask me this one because I very clearly said joke 1. I said use this instance of the class. If I said joke2 dot print answer, well, now there's a little bit of a mismatch, right? It's going to ask the question from the first one and tell me the answer from the second one. But it's doing exactly what I told it to do, right? Like the computer's not going to understand jokes, not these jokes anyway. So it's doing exactly what I told it to do. It's referring to the instance to decide what instance variables it should be accessing and therefore printing out. So we'll see. I don't know, this doesn't even make sense, right? But from a coding perspective, I hope that it does make sense. I'm not worried about whether you like my humor or understand the jokes. I'm worried about whether you understand how this code works and why we're seeing the stuff that we're seeing on the screen. So does anybody have any questions about this little exercise before we move on to the next one? Okay. Yeah, question.
So the two instances can call the same method.
That's correct. The two instances can call the same methods, or I think another way that I would think about it is, you know, this is a riddle, so it can use any of the methods that it finds in that class. Any of them. Yep. Good question. Let's talk more about constructors. Constructors are very important, so it's not that surprising that we're spending a good chunk of time talking about constructors today. We're going to take a look at this car class next. And this car class is interesting because it actually has more than one constructor. So think about what that means. Constructors are used to create instances, right? I'm saying that I can have more than one way of creating an instance. This first constructor actually has a specific name. This is called a default constructor. So I'm basically saying, hey, if you don't tell me what you want the model and the year of the car to be, then I'm just going to set the model and the year to be some default values, right? Just give you a generic car. So the way that that would look in the code would be to say, all right, model, it actually tells us what it wants these default values to be. It wants the model to be, this is just the empty string, which I don't actually like that a whole lot, but I'll roll with it for the sake of the example. It wants model to be equal to empty string, and it wants the year to be equal to 20, what did it say, 2019. Okay, fine. Now notice these, unlike the last examples we saw, did not come from parameters, right? So this constructor is used to just create a generic car, just to create a default car. If I want to make a specific car, I want to make a car that represents a specific car, then that's what this constructor is for. So down here you can see that this constructor does take in parameters. So if I want to create an instance that represents my 2022 Toyota Highlander, right? I could plug in 2022 and Highlander for the input parameters, and the car that gets created would represent that specific car that I want. And so, like we saw in the prior examples, we'll set these instance variables using the parameters that were given. These are the two ways that you'll commonly see to set instance variables. One is to just set it to some constant value, some known value, some decided value. The other way is to take it in as a parameter and set it that way. And we can do it both ways. We can actually, so again, we have multiple constructors here, two ways to create a car. For every instance that I create, though, I'm only going to use one of these two ways, right? I can create a car using this way, or I can create a car using this way, right? But for one instance, I only need to call the constructor one. I only need to choose one of these constructors to create one instance. I hope that makes sense, what I'm trying to, the point I'm trying to get across. I would never use both of these constructors upon one instance, right? That's not how constructors work. But to kind of further illustrate how these work, we're going to create two cars down here, one that uses the default constructor and one that uses the more specific constructor. And so to use the default constructor, I would just say new car. And notice there's nothing inside the parentheses, so that is how it's going to determine that it wants to use this version of the car constructor. For the other one, I'll try to replicate my car, so I'll say new car, and then I'll plug in some values. It's a Highlander from 2022. So this will actually create a very specific instance of a car to represent my car. And you could replace those values with your car if you wanted to create an instance to represent your car. And so, just like we saw in prior examples, when I print out the information, I expect this first print statement to print out the default info up here, since that is the instance upon which it has been called, right? And then for this one, I expect it to print out the information for my car, since that is the instance upon which it has been called. And if we proceed along, we'll see that that is, in fact, the information we get. Here's the default car, and then here is the non-default, more specific car. The big point of this example, though, I mean, this is always good to reinforce these ideas, but the big point of this example is that you can have more than one constructor, and actually you're not even limited to two. I can have as many constructors in a class that I want. That being said, I think it would be surprising to find more than a handful of constructors, like 2 or 3 in a class. It is definitely possible to do, and pretty common, I would say, but uncommon to have more than a couple. The other thing to notice is, how these are set. They can be set either via parameter or just by being set to some constant. Any questions on this example before we move on to our next one? Okay, so let's talk about that word private. Now is finally the time to come back and talk about that word private and why exactly we care about it. Here's a class that represents a student. And so you can see that, okay, there is a name and an email and an ID associated with the student. That all seems good. I'm actually going to go off, and what I want to do is imagine for a second that we are using this student class as part of a much larger program, right? Maybe I am running a university and I want to keep track of all the different students at my university and have a big database with what classes they've taken, and they're great. I mean, WashU probably does have something exactly like that, right? So let's pretend for for a moment that we are trying to do a similar kind of thing. And so I'm going to make a new class that I'm just going to call it, test student or something like that. And let's assume that, oops, I meant to put a main method in here and I forgot, but that's okay. I'll type it up real quick. And let's assume that somewhere, I'm going to make a student me equals new student, and I have to specify what my name is and my email and my ID number. Okay, cool. So I'll say my name and my email and my ID number, which I'll just make a bunch of 9s. Oh, I forgot the void here. Okay, so here's a student that represents me. And let's pretend that sometime later on in the program, do a bunch of stuff. And then sometime later on in the program, I'm like, what is that student's ID number again? Tell me what that ID number is. Obviously, I can see it right here, but let's pretend that there's lots of code here, and I just need it. I need to access that ID number for whatever reason, right? Okay, so how can I do that? I can try to say me.id, right? But this is a little bit, so I'm trying to say me and then grab the ID number since it's given to me as an instance variable. And this seems like it maybe sort of makes sense. But the error message that I see here, it says the student ID is not visible. And that actually is a demonstration of what the private keyword is doing for us. The private keyword says that if this is marked private, I can use this within this file, within this class, all I want to. Nothing can stop me from using this instance variable inside of the student class. But if I am outside of this file, if I am outside of this class, I cannot access this variable directly. I'm not allowed to. It's private. It's only for internal use within that class. So then you might be saying, okay, in order to do this then, you have to make this public, right? And that is certainly one option that we can consider. Let me go back here and just switch this up to be public instead of private. You probably already know that this isn't the answer I'm going to end up on because I've told you that these should be marked private, but let's explore for a second what it means to call this public. If I come back to my code now, oops, I need to save the change that I made. And then if I come back here, hopefully it will tell me that, okay, yeah. If I try to print out this thing now, it's going to tell me that everything is okay. So if this was still marked private, I would not be able to access this and print it out. You can change it back to private if you want to try it out. You'll get that is not visible message that we had a second ago. I changed it to public and now everything's cool. I can actually run this code and it will happily print out the value. And so some of you might be wondering, well, what's the big deal then? It seems like that solved the problem for us. But consider that because that is marked public, I can now also do something like this. So this statement is not printing out the ID. It's actually going to change the ID. It's going to erase whatever it used to be and make it a new value. And because it's marked as public, it's not going to stop me from doing this. I would argue that's a big problem. I oftentimes want to know what somebody's student ID is. I want to see what that value is. But student IDs don't change. I mean, maybe sometimes they do in very extreme situations, maybe. I could imagine the student ID having to change. But for the most part, once you get that student ID, it's set in stone. It doesn't need to change. You don't want anybody to change it. It would cause serious problems if it did get changed, because that's tied to your academic record and all this other stuff. So we are okay with doing stuff like this, but we're very much not okay with doing stuff like this, because that seems like a huge risk to allow somebody to just change a value like that. So, marking it as private solves that problem. But then we run back into the problem of, well, I can't do this anymore, right? So which way is the right answer? How do I reconcile this? If it's marked private, this one doesn't work, but this also doesn't work, and that's a good thing. If it's marked public, this does work, that's a good thing, but this also works, and that's a bad thing. So they both have their pros and cons. Well, the answer is actually we're going to use private. We're going to mark private and do something a little bit different, which is to come down to our list of methods and create something that's called an accessor. Or you might hear me refer to it as a getter. Getters and setters, it's the same category of things. Getters and setters are very common methods whose whole purpose in life is to provide simple access to our instance variables. So instead of using public and private to access these, to control access to the instance variables, we're going to mark them all as private and then provide getters and setters when we need to. Getters are used to allow us to look at a value but not touch, right? We can't change it, we can just see what it is. And setters are used to change the value, make it something different, set it to a different value than what it currently is. So in this case, we don't want a setter. We were actually saying we don't want to change the ID. We just want to be able to see what it is. That is a classic case for a getter, and almost all getters, like 99% of them, are going to follow a similar format. The return type is going to be the same as the type of the instance variable. I'm going to call it getID. So that word get is going to appear a lot of times in the method names. If you see that word get out in front, you know that's a getter. That's an accessor. If you see the word set out in front, you know that's a setter. That allows me to change a value. And the body is almost always going to be a very simple return instance variable. So this is a getter. This is a getter. And if we return back to our example here, how does it solve our little conundrum? So I wanted to be able to print this out, but I didn't want to be able to change it. So I marked it as private, and you can see that, okay, this is not possible anymore. That's a good thing. I don't want this to be allowable. So marking it private fixes that, but then if I want to print it out, if I want to see it, I can't access the instance variable directly. I have to access it through the getter, through the accessor. So we're going to call our getID method. Notice the parentheses on the end here. Very clear that this is not an instance variable, but a method that we're calling because of those parentheses, which will give us that ID value. And now we have provided more of a fine-grained control, right? We've said that you can see what this value is, but you cannot change it. It's not possible for you to change it. If it's marked as public, we don't have control over that anymore. If it's marked as public, they can do whatever they want with it, and there's nothing we can do to stop them. So that's usually not what we want. So that's why we mark everything as private and then provide the getters. And if we need to, we can also provide setters. I'd like to show you what a setter looks like, just so you're aware of what a setter might look like. Let's say that somebody wants to change their name. That's actually not an uncommon thing to happen at all. People change their names, not all the time, but it definitely happens, right? So if I wanted to provide a way for somebody to change their name, I would say public void. Setters are almost always going to be void. Set name. I'm going to take in a parameter this time. Setters are always going to take in one parameter. That parameter is going to be the same type as whatever the instance variable is being changed. So in comes my new name, and I'll say that name is equal to new name. So this setter would allow me to change my name if I wanted to. Right? Before this code existed, I would not be able to change my name because name is marked as private. But if I decide that that's something that I want to allow, then I have the ability to put in the setter to make that happen. So getters and setters are very, very short methods that we use all the time. And are how we get around the restrictions of marking things as private. It's really kind of a security issue in a way, if you think about it. Marking things as private is like locking everything down, and then I generally provide access using getters and or setters as I show the need for those things to exist. Any questions about that? All right. I've got two more topics of conversation for you today. One is to chat about the next section is actually called static. And while I do want to chat with you about static things versus non-static things, I want to take a moment to say that this content that you see here on these examples is not something that I would expect to cover heavily. I'm not going to cover it very heavily today. Would also not expect to cover it very heavily on a future exam for that So for studying purposes, I would say don't worry about grinding these examples so much. What I want you to understand about static things versus non-static things has a lot to do with how we've been using them in this class. Notice that this method does not have that static word, right? And actually, none of the methods that we've been using today, have been called static. That's the opposite of every other method that we've done before today. So everything before today was static. Everything after today is not static anymore. Static things and object-oriented programming don't mesh very well. So we are not going to be using static things anymore, right? To understand the difference between those two, again, consider that in order to use these methods, I have to call a constructor to create an instance and then call a method upon that instance. Static methods don't require me to do that. I just call the method directly. Can you think of methods that we've done that with? There's actually a lot of methods we've done that with. Some that I introduced to you maybe in the first week of class. If I want to flip a coin, I'm going to use math.random. That's a static method. I don't have to call a constructor to create an instance of a math, right? What does that even mean? That doesn't even really make a whole lot of sense. I just say, here's a method that generates random numbers. Use it, right? So that's not object-oriented. That is a static method. Or another way we would say that is static methods are called upon the class, whereas non-static methods are called upon an instance of a class, which might seem like a subtle distinction, but it's a very important one. And so that's really, as far as static versus non-static goes, that's what I want you to know. Object-oriented programming does not use static methods, with the one very, very, very big exception being main. Main will always be static, and that's not going to change, and main is not going away. So main is our one static method that we're cool with using. There are other situations in which it may be appropriate to use a static method, but you're not going to see that much more in this class this semester. We're going to focus on using non-static methods. So think about what that means again for the upcoming few weeks, the upcoming exams. I don't want to see you write the word static on exam 3 at all. That is absolutely not going to be a thing that I ask you for on the third exam. All non-static, all object-oriented, all dependent upon instances. It's a shift. It's definitely a mindset shift. That's why we've got a few weeks to talk about it and hopefully get you used to it. But the last example that I want to do with the 25 minutes that we have remaining is a sort of a creative example. So I'm going to create a new class to represent a new object. This is actually what we're going to ask you to do in studio this week as well. We're going to present you with some things that you're probably already familiar with, right, as human beings, and ask you to create representations of those things in code. So how do I take something that I'm probably very familiar with as a person, but create a code representation of that thing? Let's do it. I want to do that for something that I'm assuming you're all familiar with, which is a cat. And maybe you're not a cat person, or maybe you're allergic or something, but that's okay. The code won't make you sneeze, I promise. We're going to create a digital representation of a cat today. And we're going to start by thinking about the instance variables. There's two categories, instance variables and methods. So our instance variables, again, just as a reminder, are has-us. So cat has a blank. This is where I ask you all for help. What are some things, I want to brainstorm, what are some things that might be considered as has-us for a cat? Somebody help me out here. Cat has a what? Would be some appropriate instance variables. My cat has a name, right? Just to get us started. I think that's probably appropriate. Maybe you call your cats Hey You, but mine has a name. Anything else? A breed, great. What else we got? Age, okay. Any others? I'm sorry? Favorite, did you say favorite toy?
Yeah.
Yeah, nice. Cardboard boxes, yeah, oh. If it fits, I sits, right?
Yep.
My cats do the same thing. Cat has, so here's an interesting one. Cat has a voice or a meow. So I have two cats. They don't sound the same, right? They both talk to me, but they don't sound exactly the same. They have different voices. They say different things. They sound a little bit different. My cats definitely have fur. Lots of fur. Not all cats do have lots of fur. Don't Google cats without fur on it. It's very creepy, but they do exist, right? Most cats do have fur, though. Any others you want to throw on the list of has-us? Notice these are all nouns, right? These are all things. These are all attributes that we use to describe cats. And so I don't know if we'll have time to do all of these, but I definitely want to do, some of these with our cat. And so I would probably pick out name and age is good, and maybe voice and fur, and make those into instance variables. So again, private. First thing I'm going to write down anytime I'm talking about instance variables. Always, 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 always private. If I'm doing the name, that'll be a string, right? String name. If I want to do age is probably an int. If I want to do voice, what a cat sounds like, that's probably also a string. And if I want to do fur, I know this might seem a little bit silly, but like, how would I represent that? That might be literally the number of hairs that they have on their body. Could also be an int, right? And if you wanted to, if I didn't do the instance variable that you wanted to, you're welcome to add it, right? You don't have to rely on me. Here's actually another interesting one. I'm not gonna actually code this one up to completion today, but I want you to think about this. Cats also have a mother, and the type of that would be cat. Is that a little too mind-blowing for today? Do you see what I'm getting at, I hope? Right? Anywhere that I used a type, I can now use cat, right? So if I truly have another cat that I want to point at that represents that cat's mom, I can do that, right? This is good. This is a good thing. This allows me more flexibility in my code. This allows me to represent things that I can't represent with just ints or doubles in my code, right? I'm now using a complex object to represent a piece of information as opposed to just a single number or string. But that's maybe a conversation for next week or the week after. For now, we'll stick with these four simple ones and move on to our constructors. So the next category of things is methods, but I always start with the constructors. Always, always, always start with the constructors. And for each of these, I'm going to ask the question, right? Do you need to tell me what this information is? Or do I already know what this information is when I create this brand new cat. So for example, right, I don't know what your cat's name is unless you tell me what that cat's name is, right? You have to decide on what your cat's name is and tell me what that is. There's no way I could possibly know what you want your cat to be called unless you tell me. So when I create my cat constructor, I'm going to bring in a string parameter called name to represent what that cat is named. When I think about the age, do you have to tell me how old your cat is? I think actually there's an argument to be made here that, you know, if I want to represent the cats that I have at home, I do have to tell you how old they are. But let's think about this in a different way. I'm creating a brand new instance of cat. So before the cat didn't exist, now the cat does exist. I think there's also a strong argument to be made that I know what the age is. The age is 0, right? I just created it for the very first time. So that is, I think, one that could go either way. Do I want to include it as a parameter? Do I not want to include it as a parameter? I think that could go either way. For the other two, I think I would include them as parameters. And so then when we set the instance variables, right, if I have the parameters, I can just set them directly. But for this age one, I'm saying that all cats that get created are going to have an initial age of 0. And maybe that'll change later, right? I can create a setter if I want to allow me to change the age of my cat. Or I can make a method called birthday, right? I don't know if you all celebrate your cat's birthdays, but you could have a birthday method that bumps their age up by 1 every time they have a birthday, right? That's something that you could do. If you don't like this, option, then you can also include age as a parameter, or you could do it both ways. I could make a second constructor, and I could have one constructor that accepts age as a parameter that makes cats that are 0, and I could have another if it accepts age as a parameter, it will make cats with whatever age you want, and I could have a second constructor that doesn't take in an age and only makes cats that have an age of 0, right? Those are both possible ways forward. The way that you choose depends on the problem you're trying to solve. What are you trying to use these cats to do? What's your ultimate goal here? That should dictate your final choice. But if I finish along with the rest of these, you'll notice that I've run into a problem here. Maybe you have been wondering, like, what the heck's going on here? These lines don't look quite right. They don't look the way that they did in prior examples. This didn't turn blue. That's a little confusing. And actually, you'll notice that there's a little bit of a ambiguity here, right? I've got this parameter that is called name, and then I also have this instance variable that is called name. Those are two separate variables. I hope, does everybody feel okay about me saying that? Those are two separate variables that happen to have the same variable name called name. So how do I disambiguate between those two? How do I tell you whether I'm referring to the instance variable or the parameter? Well, in practice, if I don't make any distinction, it thinks I'm referring to the parameter. So the fact that neither of these turned blue means that both of these are actually pointing to this, which is bad, right? That's not what we want. I want the one on the left to be the instance variable and the one on the right to be this parameter. There's a special keyword that we use to disambiguate in this situation. So this is a special keyword. You can see it turned dark purple, bolded purple, to indicate that it knows what I'm talking about. This is how we refer to anything within the class, anything within the current class. So if I say this.name, I am referring very specifically to the instance variable, not the parameter. In past examples, I didn't have to say that, and if you're wondering why, notice that the parameter had a different variable name than the instance variable did. So a lot of people do it that way, very intentionally, so that they don't ever run into this situation of having that ambiguity, and that's okay. That is totally okay. But I very intentionally did run us into that ambiguity so that I could talk about how we can resolve that ambiguity, because we can use the this keyword to refer to specifically an instance variable within a class. And sometimes it's necessary to do that, to resolve ambiguity, any ambiguity that might take place. To get really, really, really specific about what this means, right? This refers to the instance of this class upon which we are operating right now. So if we go back to some past examples, right? Like the person example that we did right at the beginning. When I say p1.print, I go up to the print method, and within this method, this would refer to p1, since that is the instance that I called this upon. And then if I say p2.print, then within this method, this would refer to p2. So the this keyword, quite literally, is whatever is on the left-hand side of the dot, the instance upon which the method is being called. Again, I know that's another confusing concept. Thrown a lot at you today, so please, if I can clarify anything, or if something I said isn't clear and you want me to say it again or find a different way to say it, I would love to do that for you. But if I don't hear any questions, then let me go ahead and finish putting this dot out in front of these to disambiguate. Or maybe you went and changed the parameter names. I mean, that's also an acceptable resolution to this problem. But at this point in time, we have set up our instance variables, and we've created a constructor. And now we can think about what other methods a cat should contain. So can do. So what are the kinds of things that a cat can do? Can somebody, this is your turn to help me out. What are some behaviors that cats have? What are some verbs that you would often associate with your feline friends? Sleeping. They do a lot of that. Did you say snacking?
No, slapping.
Slapping. Oh, like playing, yeah.
Oh no, it ain't playing.
Oh, okay. You have one of those mean cats, huh?
Every time I have to put a noise or video while I'm sleeping, otherwise my cat thinks I'm dead, so he just goes to sleep. I'm not joking.
I believe you. Yeah, no. I'm sorry, but I also believe you. Yeah. You must really love that cat to put up with it. I don't know.
Funny thing, I put in something to stop the cat duel. Unfortunately, the cat is the boss of my two dogs, and the two dogs doesn't know better, so they just push the thing aside, and then he just went in and do the same damn thing.
Wow. Yeah.
There's no saving.
You need to make your cats start paying the rent if they're going to be that much in charge. Yeah, I mean, a lot of these are going to be pretty straightforward. Eating, sleeping, meowing, right? And then shedding. Right, my cats do a heck of a lot of that. I have to be very careful not to pet my cats in the mornings on my way out to work. Otherwise, I end up covered in cat hair on the way out the door. And this is, again, not a complete list. I mean, cats, they only do so much, right? But you could add more things to this list. But these are going to become methods. These are going to become methods that our cats can, use to express their behavior. So we probably won't have time to do all of these, but let's do maybe a few of them where, like, I think meowing is a good example where I can say, okay, public void. I can't really think of what a return type should be, so I usually just use void as a placeholder, and then if I think of a return, I need to return something later, I can always come back and change it. So public void meow, and I really think that this should just say system.out.println, voice, right? Just print out whatever your cat likes to say. Shedding, so public void shed would, say this dot fur minus equals 100, right? Shed 100 hairs. Or maybe that's not good enough for me. Maybe I want to have a parameter here that says exactly how much they're going to shed, right? Maybe your cat sheds more or less. So you want to be able to tweak that, and you don't want it to just be shed 100 hairs every time. Like, that's okay. You can tweak the behavior of this. But the thing to keep in mind is, look, I'm accessing instance variables here. I'm accessing an instance variable here as well. And I even used this to do it. Did I have to use this here? No, actually, if I take this off, it actually still works exactly the same way, but it doesn't hurt anything to include it on there. I think the bigger point I'm trying to make is that these methods rely on the instance variables. It is our job to think about, okay, when a cat sheds, how does that affect the instance variables? In fact, I might even want to update this a little bit more to be like name says, whatever it needs to say. Okay? And so then finally down here at the bottom, with the few minutes that we have left, I'm going to create a main method. And in my main method, I'll create a couple of cats to represent, cats that I have at home. And so my first cat will be called Franklin. And, his name is, of course, Franklin. So I'll plug that in when I call the cat constructor. His meow, Franklin is definitely the more social cat of the two that I have at home. So he's more of a meow kind of a guy, you know what I mean? And what was the last instance variable? His fur. He is not the one that I'm most worried about shedding. He does shed, but he's not the biggest offender when it comes to getting cat hair on me. So I'll give him a modest 10,000 cat hairs, right? And then for the second cat, I can say, so my second cat's name is Lindsay. We'll make a cat to represent Lindsay. And Lindsay is definitely a bit more shy than Franklin. She's more of a mew kind of a cat. And Lindsay is the shedder. Lindsay is the one who seems to have an infinite number of hair on her body. I don't know how she manages to grow it back so fast, because half of it ends up on me every time she sits on my lap. Lindsay is the big culprit when it comes to shedding. And so now, we have successfully designed an object to represent cats, and then, decided what we wanted our cat attributes to be, created constructors, and then use those constructors to create instances of cats that represent things that we know in real life. I hope that if you have cats at home, you didn't make my cats, you made one that represents your cat, right? Because that's more relevant to you. And then to really, put these cats to work, we have to use some of the methods that are contained here. So if I wanted to, I could say, Franklin is going to meow. Right? Franklin.meow says make the Franklin cat meow, and then Lindsay.meow would make the Lindsay cat meow. And when I do this, we'll see, just like we've seen over and over again with the prior examples, that when the meow method runs on Franklin, it uses Franklin's instance variables. So it's going to say Franklin says meow, and then when I run the meow method on Lindsay, it's going to say Lindsay says mew, because that's what she sounds like. And if I wanted to use the shedding method, then I could use that method as well. Although I might want to try and think about some other methods that would need to be potentially part of this as well. Because I see a problem. For instance, if this has never happened, right, in real life, but we're talking about code here, not real life. What if there's no more fur left? I don't want my cat to have negative hair. Like, what does that even mean? You know what I mean? Like, that's not a thing. It's not a thing that exists. So maybe I need an extra check here to make sure that there actually is hair to shed. So, if this .fur is greater than 100, then we'll shed our 100 hairs. And furthermore, maybe I want to have a getter, right, to see exactly how much hair my cat has remaining, because if they shed a whole lot, then that's something that I might want to know. So, the simple getter would say something like return fur. And then one of my favorite things to do is to, come down here and say something like while Franklin.getFur is greater than 0 and Lindsay.getFur is greater than 0, then we'll make both cats meow and we'll make both cats shed. And now when I run this code, right, you've got my apartment on a typical day where my two cats run around meowing and shedding all over the place until one of them has no more fur left to shed, right? And then it stops. Yeah, or they go to bed, right? Which they do quite a large amount of the day, right? So in 15, 20 minutes, we were able to create an object, create a class to represent something that we're familiar with in real life, and then give it some basic functionality, give it some attributes, and tell a little story with it, right? That's powerful. That is very, very, very powerful. I hope that this conversation will get your brain rolling, because once you do this enough, you'll start looking around and just seeing objects everywhere, right? You'll look at the table and think, oh, table.height, and you'll look at the door and be like, oh, door.open parentheses, right? Because that's the behaviors that doors have, and you'll start looking at all the objects around you and thinking about how you can fit them into this instance variable method class kind of situation. That's what I'm trying to train you to do for the last few weeks of this semester. So this is taking way longer than I thought it would, but that's okay. We've covered enough ground for today. I know it was a lot. Please let me know if you need any more help. I got plenty of appointments later on in the week if you want to come in and go through these examples again. Otherwise, I will see you in the labs on Wednesday. Have a great week, everyone.